the interpretation. So we need to go back to the Google Doc and now start explaining what our data actually means now that we've stated what the numbers themselves are. So we're going to add a discussion section after our results, and then we're going to explain what these results mean for MA students, staff, teachers, parents, and or administrators. We're just trying to say what this means, not necessarily what people should do. We're not making recommendations, we're just saying that this is what we have found in the context. You know, a little bit like your MCL grading. This is explaining in context what your numbers mean. Remember, we also need to explain how accurate our prediction is. We need to explain what the R-squared value means. And as an example of what your data says and what it means, we have already randomly selected a number to plug into our optimized equation. We're going to say what the result is and, again, what it means. So we have some good sentence stems to start our discussion here. Again, explain how this affects each group, but try to steer away from saying what any group should do. So I've got this up on another screen, so let's take a look at some of my results and my examples. If you might remember from the Task 7 video, I randomly plugged in the number 8. And I just noticed, I made a little note of that. I also have gone back and put in, not the best photos, but some photos of my quadratic regression equations residual plot and the other linear regression residual plot. I reused that original picture because it ended up being the same equation that was my best. But anyway, keep that note here for a moment, and I'm going to add the discussion, which starts with, we used a random number generator to select 8 as a value for our explanatory variable. And that takes care of my when I plugged in 8. Our model predicts for this explanatory value the response variable's value will be 16.239. Now, one of the things that I forgot to do here was I forgot to include my units of measurement because, again, this is part of the discussion. So, again, 8 miles from school as opposed to 16.239 absences or tardies. And that took care of my little note here, but it's in slightly more academic language. If I go back to my notes about R squared, the R squared value of our optimized regression equation is 0.067. Which means that our model has an approximately 6.7% rate of accuracy in its predictions. So that already tells you that our predictions are not that great. Now remember to turn R squared into a percent rate of accuracy. You just multiply it by 100, or you just move the decimal 2 places to the right. So now, explaining what this means for each of our groups, the students, teachers, administrators, and staff, and parents. And this is where you get to be a little bit more creative, a little bit more thoughtful. Again, we're trying not to make recommendations or saying that what people should do, but just saying what people should be aware of or what people could know. I'm trying not to use the word should here. For MA students, this means that the farther one lives from school, the more likely they are to miss some of their first period class. Some or all. Yeah, sorry, it wasn't just about first period, it was their first class of the day. If you want to say why, you might make up some, or not make up, think of some reasonable reasons why somebody might be late or miss school, such as they may have difficulty parking, or get caught in traffic, or have public transportation delays. Which would account for more absences and tardies. However, our rate of accuracy is not that good, or our rate of accuracy is not that high. So the precise number of absences or tardies cannot be accurately estimated. Or accurately predicted is also a good suggestion. If you have an R squared value that is above or 0.5 or above, then you actually have a pretty strong predictor. But I think what probably happened in my particular example was that the primary explanatory variable was not distance away from school that causes absences or tardies. There was probably some other variable that I hadn't considered. But that would only be if we were talking in the discussion about how we might do some of this in the future if we were going to redo the project. But that is a different type of project, so we're going to just go on and talk about for MA teachers, administrators, and staff. This means that they should be aware that students who live farther away from school are more likely to arrive late. Pretty much the same thing it meant for students and for students. We don't have to explain why, because we already explained why students may be late in the previous paragraph or the previous part. But I'm going to copy this idea because, again, we need to be clear that our rate of accuracy is not that high, though. So the precise number of absences or tardies cannot be accurately predicted. If you wanted to add an idea like the general trend, of farther distance and higher tardiness or absence holds true, but specific numbers cannot be predicted. That's another way of saying the same thing. And maybe now I've said the same thing twice, so I can edit that out. Maybe just keep the idea of because our r squared value is so low, the general trend of further distance and higher tardiness holds true, but we can't, again, specific numbers can't be predicted accurately. So for MA parents, our last group here, this means that they may need to assist their young people in getting out the door and to school a little earlier if possible. Maybe not just if possible, if circumstances allow. Again, our rate of accuracy was very low. So although we can state general trends, we should not make specific predictions with our model or with our current model. Maybe we'll get a better model later. So again, that little explanation of what my r squared value means does appear in all three parts of the paragraph, but I tried to state it in a couple of different ways. It's 0.067, which is a 6.9 rate of accuracy, which is low. It's lower than 50%. We can't really trust it. Even if it was 0.499, it's still below 50%. We can't really trust it. Again, just stating that we can't accurately predict any specific values, but our general trend, our general relationship is true. Whether you have a positive or negative association is still going to be true. But that is the discussion section.